what we have is a mechanical circuit, which is an analogy to an electrical circuit here. So we have a tank filled with water, and that water is going to be the pressure, right? And we have a valve, which is going to be a resistance to the flow of water, which will go through this pipe. As long as that valve is open at least a little bit, there'll be some flow. The more we open up the valve, the less resistance we have there, the greater the flow, as long as the pressure stays constant. As long as let's say if we had an automatic filled tank here, which would keep a certain level, right, we would have a certain flow that would stay steady as long as this resistance, as long as this valve position stayed the same. But there's this inverse relationship between the resistance and the flow. As the resistance increases, right, if we close down the valve, the resistance increases, the flow decreases, and vice versa. And if the valve is in one position, we'll get a certain flow, but as the level rises, we'll get a higher flow because we get more pressure pushing that water. And as the level goes down, we'll have less flow if that valve is still in that same position, steady position. So you see the relationship between pressure, resistance, and flow. Well, with an electrical circuit, we have the same relationship between pressure, which would be the voltage. That's the same as pressure because that's the pressure that's going to push the electrons. And I is the symbol for current, intensity of current, right? And that current is dependent on the pressure as well as the resistance to the flow of the electrons, the resistance to the flow of current, right? And that relationship is Ohm's law, and that is current equals voltage divided by resistance. Or we could look at it as the flow equals the pressure divided by resistance. And I'll draw that again down here. The current, and this is Ohm's law, is the voltage divided by resistance. And that's the same as saying that the flow of the electrons is equal to the pressure put on the electrons by the voltage source divided by the resistance. And the resistance would be the load. Different loads have a different resistance. So for example, if the resistance here was 5 ohms, ohms is the unit for resistance, right? We would have a current of the 30 volts divided by the 5 ohms, which would give us the 6 amps. But let's say we increase that resistance. What's going to happen? Well, remember the inverse relationship. If we increase the resistance, well, let's say we doubled it, right, to 10 ohms. We increased that resistance to 10 ohms. We doubled it. Well, we still got that relationship that we had over here. As the resistance increases, the flow is going to decrease. So the flow is going to be the 30 volts divided by the 10 ohms. Which is going to give us 3 amperes, right? So you see that the current is half as much when the resistance doubled. So when you think about the relationship between current, voltage, and resistance, think about pressure, voltage is pressure, current, I here is current, is flow of electrons, and resistance is a restriction. So similar to a mechanical setup.